Please join me in welcoming on stage Shri D.P. Mathuria, Chief Engineer, Planning and Development Organization, Central Water Commission, Government of India. Please give a big round of applause as the panelists join us on the stage. Dr. Manoj P. Samuel, Executive Director, Center for Water Resources Development and Management. Bilash Kumar Bera, Engineer-in-Chief, Public Health Engineering, Bhubaneswar Municipal Corporation, Water Supply Sanitation Board, Government of Orissa. Sir will be joining us shortly. Shri Ajay Saxena, Sector Head, Infrastructure Development and PPP Head, Maharashtra Institution for Transformation. Dr. Diganta Burman, Head, Water Resources Division, Northeastern Space Application Center. Professor A.K. Keshri, Water Resources Section, Civil Engineering Department, Indian Institute of Technology, Delhi. And to moderate the session, I request Shri Salil Shrivastava, Engineer-in-Chief, Nava, Raipur, Atal, Vikas, Pradhikaran, Government of Chhattisgarh. Please welcome all our panelists with a huge round of applause.
Thank you, APAC. Thank you, Department of Jal Shakti. I'm Salil Shrivastava, Engineer-in-Chief, Naya, Raipur. Our topic for the panel today is State's Perspective, Harnessing Emerging Technologies, IoT, AI and Big Data for Water Governance. We have various friends, senior officers and senior functionaries from various organizations who we will be discussing on. Before going ahead, just to set the tone, we at Naya Raipur have done IoT and IT interventions, ICT interventions in our water. In fact, we have done a lot of that, but only with reference to water supply to the city. I will make a small presentation and then we will start the panel. So, could you please play? Yeah. Hello. So, okay. So, just to brief you about Naya Raipur for those who do not know, Naya Raipur became a new, when the Chhattisgarh state was carved out of MP and Raipur was named as capital, the existing Raipur city did not have the infrastructure basically to hold the capital functions, and therefore a new city was planned. So Naya Raipur is the new city which has come up with the vision where of course the capital functions, and it was also planned as a financial hub with employment generation and state-of-art physical and social infrastructure. Environmentally, we wanted it to be a green city and a smart city with conservation of environment and existing landscape, promotion of specialized non-polluting industries. With reference to, we wanted it to be a city for all, inclusive housing and mobility, a citizen-friendly and a visitor-friendly city with sense of security and comfort. So the total plan area of the city is 234 square kilometers. The map which you see, we have divided it into 3 layers. Layer 1 is the core, layer 1, which is 80 square kilometers. All this area is with Naya Raipur Authority, and we have developed all the infrastructure within this 80 square kilometers or 8,000 hectares, that is 20,000 acres. Layer 2 is the green colored which you see. It is 130 square kilometers where we have restricted some land uses. And layer 3 is airport zone, which is grey colored, where the airport of Raipur falls. So it comes within the plan area of Naya Raipur. When you see on the left, it is the Raipur city. To the southeast of that elongated 20 kilometer by say 4 kilometer, it is the core layer 1. So we have connectivity to all major cities within 100 minutes. Raipur, in the north of the Naya Raipur, we have national highway which is Howrah-Mumbai. To the south of it, we have another national highway which goes to Visakhapatnam. And then we are doing a railway line through the city where we as authority are making 4 stations. 2 of them are constructed and the railway is plying through that. We have already done a World Bank aided BRTS project which runs from Raipur to Naya Raipur, which is ICT enabled project, again using all IT IoT solutions and within Naya Raipur. Then for infrastructure, we have already done these type of 150 kilometer of city level 4-lane, 6-lane roads. Water supply we bring from river Mahanadi, which is 23 kilometers. I'll be telling you details about that. STP of 52 MLD is already done and we are supplying through to the city. Sewerage, we have 5 STPs, which are also SCADA controlled, enabled. And we also do post-tertiary treatment, recycle the water to the city. Electrical network, all underground, we have developed 24/7, uninterrupted through ring mains also. So we have a very good power supply within the city. For telecom network, we have already laid ducts and optical fiber through the city. All our street lights we did in 2012 are LED street lights, which are network controlled. So having done the basic infrastructure, we decided to move on to the ICT infrastructure. That was in 2013 itself, well before the Prime Minister's Smart City mission. So our Smart City or digital platform had these verticals: the video analytics, city surveillance system, then utility management system, the integrated command and control with and building management system, smart network, dedicated optical fiber for the city. This was inaugurated by the Honorable Prime Minister in 2018. So where existing tracks are water, sewerage, electrical, utility management systems, citizen kiosk, health ATMs, integrated command and control center with integrated building management system for few buildings, smart governance for the authority as well as citizen interface with the authority, all type of citizen interface, including building permissions. Right from day one, all building permissions are being issued through the online system, smart signals and RLVD, where we issue the challans through this system without any human intervention, CCTV surveillance and ITMS, traffic management and transport management system. So now we come to the utility management, electrical SCADA, water SCADA and sewerage, and the street light network which we did earlier, that also we shifted onto the integrated command and control center. So now we come to the water SCADA, which I would be telling you about a little, where we have used intervene the ICT intervention. So intake well is at river Tila on river Mahanadi, where we have made any cut, and then we bring water through a raw water pumping main by 21 kilometers to a place called Pachela, where we have the water treatment plant. As of now, 52 MLD water treatment plant is functional. Thereafter, clear water gravity mains, where which leads to all 40 sectors within the city, which is almost clear water gravity mains are 51 kilometers, where through after MBR we bring water under gravity to underground reservoirs, which are 31 in numbers. This is a typical GIS layer map. On the right, what you see is the intake well. Then there are up to the WTP, there are 2 RTUs in between, and then it supplies through gravity line to various sectors. This is the distribution network with all the blues as RTU, greens as RTUs, 240 sectors. The key features of our SCADA application is the centralized command and control, monitoring the data for various sensors, alarm generation in case of system failure or any other issue, customized reporting for stakeholders, immediate action, historical data storage and data analytics and water network optimization, and then controlling and monitoring water pumps from remote locations. Here, I must tell you, normally SCADAs are one-way communication where you get the information. Our SCADA is both way. We can control all valves, pumps, motors remotely from the command and control center. So this is the intake well. We have one RTU, flow meters, pressure transmitters and level sensors at the initial intake well. Then on the way we have two RTUs, we have flow meters and pressure transmitters are there. At the water treatment plant, right now, we have initially also we have all the sensors, and then later on, before the water is released for the after treatment, the turbidity, chlorine and flow meters are there, which are sensor controlled, which we monitor from the command and control center. Then through various RTUs in between, supplying to various underground reservoirs, and at the last mile just before supply from the underground reservoirs in the sectors, again we monitor them, the TDS sensor, chlorine sensor and turbidity sensor. Of course, flow meter and pressure transmitters are also there. So this is the IoT intervention we have done, and which gives us various information regularly. The last mile also I will tell later on post the GR. So this is only the transmitters at the intake level. This is a mimic diagram basically for the equipment. At the raw water we have which one is running, it turns into green if it is functional, otherwise it is red. Then raw water pumping, as I said, we have two RTUs at 7 kilometer intervals each, where also we have pressure and flow transmitters, just to monitor that the health of the system is all right. In the raw water pump, one at village Bhurka and another is at Kathia, yeah. So at water treatment plant, right from the cascade aerator, where also I think this diagram is better to explain. This is a diagram where right at the, initially we have all the sensors to ensure what is the quality of water we are receiving at the WTP. Then we have the treatment, the flash mixer, then the clariflocculators, thereafter the filter plant, filter beds, and then the clear water. And then it goes to MBR for supply master balancing. So initially and as well as outside, once it goes out, we monitor that through the sensors, the quality of water as well as the quantity of water. The levels in underground reservoir as well as the MBR are also measured online. We come to know what is the level, how much is the quantity of water available when the operations to be done. This is also clear water gravity main, where normally pressure and flow transmitters are there. This helps us in maintaining, understanding the health of the system. If there is any leakage or breakage or any loss, we come to know through this. Once it goes to the UGR, the levels at UGR, level sensors, and of course the residual chlorine, hardness and pH, all we measure online. Operations also can happen. This is a typical distribution network diagram. This is the last mile post underground reservoir in the sector. The last mile, we are using Bhuvan's GIS data and we operate everything on GIS. So we get these details. The red shows there is some fault in the line and some leakage or something. That is what is to be attended. Whenever there is an imbalance in flow or there is a flow meter gives a different, or pressure reduces suddenly, you come to know that is. Last mile also we have used AMR meters. So automatic meter reading devices we have used. All the meters within the city. The whole city is metered and pressurized. We are giving metered supply to the city. Wherever there are bulk meters, we have provided chip, means GSM card into the meters, where we get online monitoring of the flow. While the smaller meters at home, we have done the RFID based meters, where monthly we just move around the road and get the information what is the actual meter reading. That is how water consumptions data is captured through these meters. Then complete automated solution for water consumption reading, removing and intervention. MR meters are integrated with eGov module, which also we have in our ICT platform. And therefore, one can know anytime what is his bill, what is his reading. Automatically, bill generates through the system. It is issued, and even the payment is done online. So we have a full cycle of online automated system where the technology has been used. Actually, for today's context, it was this point that yes, we are using technology at every level. Only in reference to the fault detection as of now, we are depending on the flow meters, which also we want to move it to AI and algorithm-based system. That is water network optimization and the water leakage detection system. That is what our future proposition is. We also have alarm generation at the command control center and how it is resolved. These are all those escalation metrics where we can. So actually what we have observed is the RTU locations. This is one key finding which we have. Normally pipeline runs underground everywhere. RTU, once it is underground, we have felt various locations it gets faulty because of the moisture. So that is one thing. The other is, yes, WNO and WLD, as I explained, we have to go ahead for. I think that's all from me.